This is Geometry, Unit 7, the review for quiz number 2. We're looking at the tangent of x. So when we look at the x angle, we need to identify what the opposite side is, what the adjacent side is, and across from the 90 degrees is the hypotenuse. So we use the phrase SOHCAHTOA to help us identify what sides go with the trig functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we're going to do tangent, tangent is opposite over adjacent, so 13 over 84. And then the decimal version of that is 0.15. That is rounded to the nearest hundredth. Sine is opposite over hypotenuse, so that's 13 over 85, which I believe is going to come out to be the same decimal rounded to the nearest hundredth. 13 over 84 is bigger, of course. 13 over 85 is smaller, but it's still, to the nearest hundredth, is still coming out to be 0.15. Cosine of x is adjacent over hypotenuse, 84 over 85, and that's very close to 100%. If you were to get 84 out of 85 on a test, that would be very good. So that's 98, rounded will be 99. To find the value of x, we're still going to use this phrase called SOHCAHTOA. SOHCAHTOA identifies that your opposite side, next to it is your adjacent side, it's a leg, don't forget, and across from the 90 is your hypotenuse. So that's the opposite, adjacent. Well, I'm sorry, I took it from this angle. This angle doesn't have an angle value. We need to go from the 72. We could figure this one out, it'd be 18, but let's go from the 72 and say opposite, adjacent, and hypotenuse. So in other words, it matters which side is considered the opposite. It has to be across from the angle you're going to be working from. So the 8 and the x are the opposite and hypotenuse. That's using sine. Sine of 72 equals the opposite side over the hypotenuse. So we'll put that over 1 and cross multiply. So we're going to get the sine of 72 times the x equals the 8. Then we'll divide by the sine of 72. And we need to be in degree mode with our graphing calculator. Most scientific calculators will automatically be in degree. So 8 divided by sine of 72. 8.4. 8.41. It's approximately 8.41. Here from the 42, the side opposite, across from the 90 is the hypotenuse, and of course the other leg, the leg next to the 42, is called the adjacent side. We're again working with opposite and hypotenuse. So the sine of 42 equals the opposite over the hypotenuse. Put the sine of 42 over 1, cross multiply. So 52 times the sine of 42 equals 1 times x. 52 times the sine of 42 equals 3479. That's approximately the value of x. Of course, that needs to be less than the hypotenuse. The hypotenuse is always the biggest side. Here's our angle 15. Across from the 15 is the opposite side. Across from the 90 is the hypotenuse. So the other leg is called the adjacent side. So, looking at our phrase of SOHCAHTOA, we're looking at the x, which is in the adjacent side, and the hypotenuse, which is the 50. So we're using cosine of our angle, which equals the opposite over hypotenuse. Cross multiply, so we get 50 times the cosine of 15, which equals x. 50 times the cosine of 15 comes out to be 4830. We're going to solve the right triangle. To solve a right triangle, we have to find the missing angles, which is the measurement of angle J, the missing sides, which is LK, and also LJ. So we need to find all three missing pieces. So, looking at what we have here, to find the missing angle, we know that 90 minus 62.3 comes out to be 27.7. And that is degrees. Now, from the 62.3, across from that is your opposite side. Across from the 90 is considered the hypotenuse. And next to the 62.3 is considered the adjacent side. So right now we can decide, do we want to find LK or do we want to find LJ? It's your choice. I'm going to find LK. So that's the adjacent. So I'm working with the 9, of course, and the adjacent. So the opposite and adjacent. Looking at the word SOHCAHTOA, opposite and adjacent is tangent. Tangent of 62.3 equals the opposite over the adjacent. Put that over 1, cross multiply, so LK times a tangent of 62.3 equals 9. We're going to divide by the tangent of 62.3. So 9 divided by the tangent of 62.3 comes out to be 4.73. Then, okay, 4.73. Now we're looking for LJ. You could use Pythagorean theorem here, but SOHCAHTOA works pretty well also using our trigonometry. So now we're looking for LJ, which is the hypotenuse. So we'll be dealing with the opposite in the hypotenuse, which is sine. So sine of 62.3 equals the opposite over LJ. So LJ times the sine of 62.3 equals 9. Divide by the sine of 62.3. So LJ will be approximately 9 divided by the sine of 62.3. Comes out to be 10.16. Remember, LJ is the hypotenuse, so it has to be the biggest side. So it's bigger than 9 and it's bigger than 4. That seems reasonable. If we solve for this triangle, the missing angle is the measurement of angle P. Missing is measure of angle N. And also NP, we don't know what that is. Well, let's find NP first. NP is a missing side. If we know two sides already, we can use the concept of hypotenuse squared equals leg squared plus leg squared. We don't know what the hypotenuse is, so NP squared, we don't know what that is. The leg, which is part of the 90 degrees, is 7 squared and 12 squared. So that's 49 plus 144. So that comes out to be 193. We can take our 144 plus our 49 to get 193. And when we take the square root of that, which of course is approximate to the square root of 193 is 13.89. So 13.89 is bigger than the other two legs, which we knew was a requirement. Okay, for us to figure out what angle P is, I know that it's less than 90, but I don't know what its measure is besides that. From P, the 12 is across from it. It's called the opposite side. The 7 is next to it. It's called the adjacent side. So we're looking at opposite and adjacent. So we're dealing with tangent of P. We don't know what its angle, so we're just going to put P. That equals 12 divided by 7. Notice that my one unknown is the angle. So to solve for that, I need to get the tangent away from there. I need to get the P by itself. So I say tangent of -1, 12 divided by 7 equals the measurement of angle P. So if you're going to use your calculator, you get the tangent inverse. The tangent with the -1 is said, or is pronounced as tangent inverse. Tangent inverse, you have to use parentheses, 12 divided by 7. Some calculators automatically put the parenthesis there, other ones don't. You need to have the parenthesis to be sure that you get 59.74. And that is a degree. It's not a side length. It's a degree. So 59.74 degrees. We could get the other missing angle by subtracting that from 90. Or we could do trigonometry and then see if they add up to 90. That's probably the better of the two routes to do. So we're going to now try to find n, which is opposite over, from the n's point of view, this would be opposite for n. This would be adjacent for n. Alright, that's one way you could do it, but if that's confusing, let's say 90 minus 59.74. And we get 30.26. I assume most of you will solve it like that anyway. As long as your 59.74 was correct, then that answer is definitely going to be correct also. Okay, find the perimeter and the area of the triangle. To find the perimeter, we have to find the other two sides, so we can add them all up. To find the area, I need to find the other leg, so I have base times height, the two perpendicular sides. So we have to find the missing sides. So we're going to first look from the 22. Side opposite is across from it. Adjacent is next to it. And the hypotenuse is across from the 90. So for us to figure out the x first, we're going to deal with the x, or the opposite. Remember SOHCAHTOA. Notice that I write that out for most every problem. The more times you write it, the more familiar you're going to be with it. You want to be familiar with it on test day. So, opposite is what we're looking for. Adjacent is what we have. So that's going to be opposite and adjacent. So we're using tangent of 22 equals the opposite side and the adjacent side. So 20 times the tangent of 22 equals x. So using our calculator, 20 times the tangent of 22 comes out to be 8.08. So over here, 8.08. We're ready to find the area right now because area equals half the base times the height. Area equals half the base, which is 8.08, times the height, which is perpendicular to the base. It always has to be perpendicular to the base. In this case, the 20 is perpendicular to the base. So I'm going to say 0.5, which is half, times 8.08 times 20 gives me 80.8. So the area is 80.8 meters squared. That is the area. Now, for the perimeter, the other side I need to find is the hypotenuse. Well, I have the adjacent. I'm looking for the hypotenuse. SOHCAHTOA reminds me that cosine deals with adjacent and hypotenuse. So I'm going to say cosine of the 22 equals the adjacent over the hypotenuse. And I'm looking for the hypotenuse value. You could call it y. I guess that would be okay to do. Or AC, or hypotenuse. Okay, so we're looking for the y value. We put cosine of 22 over 1 and cross multiply. So y times the cosine of 22 equals 20. We're going to divide by the cosine of 22. We need to do that to get the y all by itself. So 20 divided by the cosine of 22 is 2157. So here we have 2157. And that's our missing side for the hypotenuse. Now to find the perimeter is CT plus TA plus AC. It's all three sides added up. So the perimeter is going to be 20 plus 8.08 plus 21.57. 20 plus 8.08 plus 21.57. So that comes out to have a perimeter of 49, 67, and those are meters. Notice that that's not meters squared because we're not multiplying two meter values together. On this opposite side, we're looking at the sine of 33. Now in other problems, we've been looking for an angle that might have a sine of a decimal. But that's not what this is asking. This is saying the sine of 33 degrees has what decimal? So the sine of 33 degrees is 0.546. They're asking us to round to the nearest hundredth. So tenths, hundredths, we look at the thousand spot. If it is 5 or bigger, then we round up. If it's not, then we leave it just as it is. So 0.54. Tangent of 74, 3.787. So we're going to write down 3.487, sorry. So I'm going to write down 3.49 because the third number is 5 or bigger. Cosine of 12, 0.978. So I'm going to put down 0.98 because the third number is 5 or bigger. We round up the second number. Okay, we got some story problems. Photographer shines a camera light at a particular painting frame, or at a particular painting, forming an angle of 47 degrees with the camera platform. So what that's saying is wherever your camera is at, here's your camera. Alright, it's going to shine up there. This is where your painting is at. Okay? So it's forming a 47 degree angle with the camera platform. If the light is 52 feet from the wall, when you measure to something, you have to measure perpendicular. So your 52 feet from the wall is there. How far does the light have to travel to hit the painting? So what we're trying to figure out is what is the hypotenuse. So using the concept of SOHCAHTOA, we look, the opposite side is the actual wall that the painting's on. The 52 is how far we are, that's the adjacent side. That's how far we are away from that wall. And then the hypotenuse, which is across from the 90, is how far we are from the actual painting. So adjacent and hypotenuse are the two sides that we're looking for. That's cosine. Cosine of 47 equals 52 over the distance that we need to travel to get to the painting. So x times the cosine of 47 equals the 52. We're going to divide by the cosine of 47. 52 divided by the cosine of 57, and we come up with approximately 95.48 feet. Explain how a tangent ratio can be used to find the height of a building in the figure below. Find the height when the angle is 42. Well, explain. If we're going to do some explaining here, then we would talk about the opposite over hypotenuse. All right triangles with an angle measure of 42 degrees will have the same ratio. In this case, it's going to have the ratio of 0.9004. That's the ratio that it has to have. It doesn't matter if it's a really big right triangle with a 42 degree angle or a really small one that might fit on your fingernail. It's all going to have an opposite over adjacent ratio of 0.9004. So we'll say opposite over adjacent. Explain how the tangent of ratio can be used to find it. So we're going to use it to find it because we're doing opposite over adjacent, and all right triangles with the 42 are going to have that same ratio. So the tangent of 42 equals the opposite over the adjacent. Opposite is across from the 42. Adjacent is right next to it. So put it over 1, cross multiply, so 120 times the cosine of 42 equals the height of our building. 120 times the cosine of 42, 108.05. And the units that we're working with are feet. Okay, use a calculator to approximate the value of x to the nearest degree. Well, x is right here. We have this right triangle. It's a length of 5 on one leg and 7 on the other. We're looking for the bigger of the two acute angles. I know across from the x is a 7, which is called the opposite side, and next to it is the 5, which is the adjacent. So using the concept of SOHCAHTOA, that helps me realize which trig function I'm going to use. Opposite and adjacent, that's tangent. So tangent of our x angle is going to have the fraction 7 over 5. So we look at 7 over 5, and we're looking for the tangent value that would equal that, the angle value. So to solve for the x, I need to say tangent inverse of 7 divided by 5 equals the measurement of angle x. So second tangent, that puts the -1, that's the inverse. Tangent inverse of 7 divided by 5 gives me a 54.46 degree angle. That would be the measurement of angle X. Let A be an acute angle of a right triangle. Approximate the value of angle A. Well, if we're looking for the measure of angle A, what angle has an opposite over adjacent of 0.23? Well, if we say sine inverse of 0.23, we can figure out the measurement of angle A. Sine inverse of 0.23 equals 13.30. Those are degrees. On this side, we're looking for a cosine of an angle that has an adjacent over hypotenuse of 5 divided by 13. This time they use the fraction form. Over here they use the decimal form. So adjacent over hypotenuse, that's our cosine. So we're going to say cosine inverse of 5 divided by 13 equals the measurement of this angle A. So we have to hit second cosine to get the inverse. You need to use parentheses here. It's a requirement. It won't work without it. 5 divided by 13. So 67:38. Those are degrees. Okay, last question. You want to find the height of a tower used to transmit cellular phone calls. You stand 100 feet from the tower and measure the angle of elevation at 40 degrees. How high is the tower? How far are you from the top and the base of the tower? So if we have this tower, alright, here's our little tower, and who knows what it might look like. Let's make it do this little curvy type thing. Okay, there's our tower. We are supposed to be 100 feet away from this tower. We have an angle of elevation of 40 degrees. There's our 40 degrees. How high is a tower? The opposite is the height. Adjacent is how far we are from it. And forming the 90 degrees is across from that is considered the hypotenuse. So SOHCAHTOA tells us that opposite over adjacent, those are the number I'm looking for and the number that I have. That is tangent of 40 degrees equals the opposite, which is considered the height, over how far we are from it. Put that over 1. So, take 100 times the tangent of 40, and we find out that that is 83.91. And those are feet. Okay, that's how high we are from it. And then, how far are you from the top? How far are we from the top? That would be the hypotenuse. So we need to use the adjacent side and the hypotenuse, which is called the cosine of 40 degrees. Adjacent over the hypotenuse. That's our distance, otherwise known as the hypotenuse. Maybe that's what we'd like to write, huh? That's the side we're trying to find. So the hypotenuse times the cosine of 40 equals 100. We're going to divide by the cosine of 40. So we get 100 divided by the cosine of 40. Comes out to be 130.54. Those are feet.